In this lesson, we will study applications involving powers and roots. One important theorem that a lot of applications use is the Pythagorean Theorem. A lot of people know it as a squared plus b squared is equal to c squared. It's basically where you have a right triangle. A right triangle is a triangle that has an angle that is equal to 90 degrees, and so that's this angle here, 90 degrees. You have a pair of legs, so you have leg A, you have leg B, and the longest side, which happens to be opposite the 90-degree angle, is called the hypotenuse. So a squared plus b squared is equal to c squared could be read or understood in the following manner. The square of one leg plus the square of the other leg must be equal to the square of the hypotenuse. So leg squared plus leg squared is equal to hypotenuse squared. We're going to be using this very famous theorem for the applications that we're looking at in this lesson. In example 1, we have the viewable image size of a widescreen computer measures 21 inches diagonally and has a width of 18.3 inches. What is its height? Okay, we're going to use a Pythagorean theorem here. So if this is the computer screen, this is the diagonal, okay, that they say measures 21 inches. So what we can do is use 18.3 as one of the legs, 18.3 inches. We are using 21 inches for the hypotenuse of this right triangle. And what we do not know is the height. So let's substitute these values into the Pythagorean theorem. So we have the one leg squared plus the other leg squared is equal to the hypotenuse squared. I went ahead and plugged in 18.3 in for one of the legs. We don't know the other leg, which is labeled in the diagram as H, but in the theorem it's labeled as B. And then we do know the hypotenuse, so let me actually get rid of this. The hypotenuse is 21, so this is 21 squared, like that. And what we can do is solve this now for B. 18.3 squared is 334.89. 21 squared is 441. When I subtract 334.89 from both sides, I get that b squared is equal to 106.11. Let me move the screen up a little bit. And here I can use my calculator. First, actually, before I use a calculator, I can take the square root of both sides and find that b is exactly equal to the square root of 106.11. Now, that's an exact answer. An approximation, I can use my calculator at this point, and this says approximately equal to 10.3. Okay, so the height of the computer or the viewable image of that computer is about 10.3 inches. When you're solving these applications, it's very important to provide some type of answer sentence and also include the units, okay? Make sure to include the units. That's very important. One last thing before we move on, I just want to echo what I said earlier. This is an exact answer. Once you punch this into the calculator, it gives you an approximation. So 10.3 is an approximation. In example 2 here, it says find the length of the hypotenuse of this right triangle. So here's the hypotenuse. And give an exact answer and an approximation to 3 decimal places. Notice that the length of this leg is 7 units and the length of this leg is 4 units. So we can use the Pythagorean theorem that says that one leg squared plus the other leg squared is equal to the square of the hypotenuse. So it'll be 7 squared plus 4 squared is equal to the square of the hypotenuse. So then this leads us to 49 plus 16 is equal to the square of the hypotenuse. That is to say, 65 is equal to the square of the hypotenuse. Now, taking the square root of both sides, we find that the hypotenuse is exactly equal to the square root of 65 units. Exactly. An approximation to 3 decimal places, you can use your calculator to find that this is 8.062 units. Now, they did not give what the units are measured in, centimeters, meters, inches, yards, or whatever, feet. So we just say units, right? But again, this is an exact answer here, right? And here, this is an approximation. So that's very important that we differentiate between our answers on what is exact and what is approximate. So this is exactly equal to, and this is approximately equal to. In this third and last example, it says find the missing length in this right triangle. So notice that the unknown is one of the legs. They labeled it as B. So what we can do is we can use the Pythagorean theorem that says one leg squared plus the other leg squared must be the square equal to the square of the hypotenuse. Well, one of the legs is 1, so I'm going to plug that in for one of the for A. I'm going to leave B squared in my theorem. And then we know the length of the hypotenuse is the square root of 11, but don't forget that you have to square this according to the theorem. All right, so what we're going to do now is solve for B. 1 squared is 1, and when you square the square root of 11, you get 11. So when you subtract 1 from both sides, you get B squared is equal to 10. When I take the square root of both sides, I get B is exactly equal to the square root of 10. That's the exact value of that missing length, which is approximately equal to 3.162 to 3 decimal places. This is your exact answer. This is your approximation.